Good afternoon, everyone, and welcome to today's webinar brought to you by Rinnai, New Zealand. I'm Alice Wu, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about fundamentals of domestic water heating. While we're waiting for everyone to settle in, let's kick things off with a warm-up quiz. So, you should see a poll pop up shortly with 5 multi-choice questions. If it doesn't show up, feel free to pop your answers in the chat. Some of these might be a bit tricky, but don't worry, it's all about warm-up and we'll go through them during the webinar. Feel free to guess if you're not sure. No wrong answers here, just learning opportunities. If we have 5 questions again in the polls, and if you can't see them, feel free to pop your answers in the chat. Can everyone see the polls? Is it showing up on your chats? Great. I'm seeing some answers coming through, which is excellent. And we'll go through the answers together in just a moment. If you've just joined us, jump into the quiz now. There's still time. We'll give it another few seconds for people to respond. I know one of the questions is probably a bit hard, but I'm pretty sure Grant will go through it with us. All right. Thank you, everyone. Let's go through the answers together and see who nailed it. All right. So the first one, typical flow rate of a standard shower is, you got it right, 7.5 to 8 litres per minute. And the second question, what's the average cold water temperature in Wellington during July? 7 degrees. The next one, which is temperature, what temperature do most people shower at? I know I like hot showers, but it's 37 to 39 degrees. And the fourth question, what's the maximum amperage of a standard residential electrical supply in New Zealand? That's 60 to 65 amps. And the last one, which is quite technical, and that's why we do CBDs, how do you convert kilowatts to amps? I hope you got this conversion correctly. Excellent. So let's move on to the format of today's webinar. The format will be 45 minutes of presentation followed by Q&A. For smooth running of the presentation, we kindly ask you to submit your questions in the Q&A section and we'll answer them during Q&A time. Let's start with a 30 seconds introduction about Rinnai. We're celebrating our 50th anniversary in New Zealand this year. Rinnai's mission is creating a sustainable, healthy and comfortable way of living. We provide a range of products and services that covers climate control and water heating solutions. For water heating, Rinnai has hot water heat pump, gas infinities, hot water cylinders and commercial solutions. For climate control, we have gas fireplaces, gas central heating, electric fireplaces, Wilmington wood fires and heat pumps. Without further ado, it is now my pleasure to introduce our speaker for today, Dr. Grant Burke. Grant has been in the hot water game for over 40 years. As Rinnai's commercial hot water manager, he is the go-to guy for everything from system design and installation advice to troubleshooting faults across both residential and commercial projects. With a PhD in mechanical engineering from the University of Auckland, Grant has dedicated his career to advancing water heating technologies and sharing his knowledge with industry. His background includes lecturing in building services at AUT, and he continues to be a respected educator through Rinnai's webinar series. When he's not talking about hot water, you're likely to find Grant cycling, playing a round of golf, or enjoying time on the water. Over to you, Grant.
Thank you, Alice. So we're going to have a look today at some simple specifying of different types of water heaters. Obviously in the market today, we've got many more different solutions than what was available only a few years ago. So the first thing we're going to have a look at is a standard electric resistant element storage, so electric cylinder we'd normally call it. We'll have a bit of a look at heat pump water heaters. Question that we're getting more and more is clients that have solar panels on their roof, how they might go about incorporating those into a water heating solution. So we'll have a bit of a look at that. We'll have a brief look at electric continuous flow, mostly to explain why you can't use it for domestic installations, but we'll cover that off. Gas continuous flow, as always. A couple of others that we just really didn't have time for today. One of them is wetback water heaters. It's just a big topic and we don't have time to cover it. We have a range of wetback water heating solutions. So if you're after any information, please get in touch with the team and we'd be happy to help you out with that. And solar thermal, again, we have water cylinders for solar thermal applications, but it's become such a tiny part of the market that we don't want to devote time to it here today. So that's what we'll cover off over the next 30 or 40 minutes. So if we start with a simple electric storage water heating system, how does it operate? We've got a piping system connected to it. We've got a mixing valve that's going to limit the temperature to below what would scald you quickly. We've obviously got a shower mixer or a tap mixer, and we've got cold water comes into the bottom of the cylinder. We have hot water coming out of the top of the cylinder. When we have flow, we mix the hot and cold at the mixing valve and we reduce the temperature. That's what's being fed to our shower mixer, where we combine it with cold and we get the shower at the temperature that we like. Now, typically we might have a 10-degree incoming cold water temperature. We need to have the storage cylinder above 60 degrees to disinfect for Legionella. So let's say we're at 65. That water temperature comes out of the top of the tank. Since the 2nd of November last year, new fixtures need to have 50-degree water. Previously it was 55. So we reduce that water temperature down to 50 degrees, and then we reduce it further to our showering temperature of around 38 to 40 degrees. So that's a very simple plumbing installation, what most of us will have in our houses if we have an electric storage water heater. With the change to 50 degrees, many clients may find that 50 degrees, depending on their lifestyle, is not quite hot enough at their kitchen sink. It is possible to ask the plumber to take a straight hot water feed to the kitchen and laundry sinks. That's permitted under the rules. If the water heater is set to a higher temperature, they may fit a second mixing valve onto the kitchen laundry supply to supply something a bit hotter than 50 to those fixtures. So if we have a look at specifying electric storage water heaters, there's three things that we need to think about, three main things we need to think about when we're specifying them. How big do we want it? How fast, if we run it cold, how fast is it going to heat up again? Now that's a function of how much electricity is available and how big an element we've got in it. Bigger the element, the faster it'll heat up again, and where we're going to install it in our project. So let's have a look at those things one by one now. So we have a look at volume, lots of different sizes. Which one do we want to choose? So if we have a look at a water cylinder and we've turned the shower on and we've started water flowing out of it, and the element's not big enough to heat the water as it comes in. So the temperature, while water's flowing, the temperature of the water will drop slowly. So once we've got to about 90% of the volume of our cylinder, we'll have that sinking feeling in the shower where the water temperature is reduced a bit and it's going to run cold shortly. So we've typically got, if you take the volume on the outside of your cylinder, you'll get about 90% of that volume out before you get that lukewarm water starting to appear. So let's say we're in Auckland and we've got 4 people who each enjoy a 10-minute shower. That will use of 60-degree water in the cylinder, about 40 litres of hot water, because it's mixing some cold with it. We only use about 40 litres at 60 degrees. So we've got 160 litres of hot water that we want to get out of our cylinder so that everybody can have a shower. So if we divide that by our 90%, we come up with 178 litres. So in other words, 180 litre storage cylinders required in order to get 160 litres of hot water out of it, which is typically why, certainly in Auckland, we have a 180 litre cylinder for a 3-bedroom, 4-person house. In the South Island, where the incoming water temperature is colder typically, we might have a 250 litre cylinder to account for that. So in order to specify that volume, we really need to know how many people are going to be showering, over what time period are they showering, are the 4 people all wanting to shower in a morning peak, or is it going to be split between morning and afternoon? Are there regular baths? Because the bath will take a big proportion of the volume of the water heater. So we need to bear that in mind and add a bit if there are baths that are being used regularly. So the second thing we're going to have a look at is the recovery. So in other words, how big an element can we put in it? Now, for the first time at the Auckland Home Show this year, we had people walking around with a notebook, and they were adding up how much electricity, the various things they wanted to have in their house, so they could stick within the house supply of 65 amps. 10 years ago, there would have been people wanting gas hot water, gas central heating, gas cooking, and this wasn't a factor. But trying to stay under 65 amps, particularly if you're wanting to have an induction hob, is becoming more and more of a challenge. So we need to be mindful of what our water heater is going to do. So we can have a range of elements in our cylinder. A 2 kilowatt element will use only 9 amps, but it's only going to heat 34 litres of water an hour. So it might take 6 hours for a 180 litre cylinder to heat up. And you can go right up to 2 5 kilowatt elements, or even to a commercial cylinder, where you're going to be heating the equivalent of 180 litres of water in an hour. But at that, you're using 44 amps, which is a big proportion of your house supply. So you wouldn't be specifying that for a standard house supply of 65 amps. You can contract to go to 100 amp supply, and you can also investigate getting 3-phase supply, but down the track they may add both installation cost, and in future it could well add additional line charges. So most people are trying to stay within the 65 amps. If we go on to our commercial cylinders, so this is what we might specify for a large house that might have a lift, it might have pool heat pumps, ducted heat pumps, and so they've gone to a 3-phase power supply, and these will heat water much more quickly. So for customers that don't wish to have a gas solution, but they've got a large multi-bathroom house, 1 or on occasion 2 or more of these can be specified to give a large volume of hot water with electricity, and it's a reasonably priced capital cost to do this. So one thing that you might not be aware of is there's some tricky things that you can do with your elements to give you a little bit more hot water, or hot water a little bit quicker, without running up too much of your 65 amp allocation. And that's particularly the case if you look at a twin element cylinder. So here we've got the Rinnai 250 litre indoor-outdoor cylinder that has 2 elements. The first option is we organise those 2 elements in what we call non-simultaneous. So the top element turns on first, and it heats the top 45 litres or so of water, which is enough for a shower and a sink of dishes. If that's a 3 kilowatt element, it'll take about an hour to do that. Once the top is heated, the thermostat there automatically switches to the bottom element, and the bottom element will finish off heating the cylinder. So what this arrangement does is it gives you some hot water quickly, and you've only got 1 element worth of power at a time. It's a modest additional cost to go to this twin element non-simultaneous cylinder, and as you'll see if we go through this webinar, these cylinders offer a lot of flexibility. Standard, it comes with 3 kilowatts, and if you've got sufficient power available, you can upgrade the elements to 5 kilowatts, but again, you only have 1 5 kilowatt element going at a time, and you'll heat your cylinder much quicker if you happen to have run it out of hot water. So non-simultaneous, the 250 and 280 litre Rinnai cylinders come standard from the factory with the elements organised in a non-simultaneous fashion. So you might want to consider that for your next project, just to get a little bit more hot water quicker to your customer. The next solution is allow both of the elements to go at the same time. So for the Rinnai product, a simple field conversion, there's a piece of wire that's supplied with the cylinder, converts it so that both elements will come on at the same time. You need to plan to do this for your project because the electrician obviously needs to run a much bigger wire to the cylinder, and they need to have a bigger breaker on the electrical distribution board. So absolutely you can run both the elements at the same time. Once the top of the water heater is heated, that element will turn off and the bottom element will heat the bottom of the cylinder till it's entirely heated. The next thing we can do is come with two power connections to our water heater. So many of you will be aware, if you've been searching for an electricity retailer recently, that there are different tariffs available. And often you have an option of a continuous or an interruptible tariff. Often, depending on where you are in the country, the interruptible tariff will be lower. What that means is that at peak times, the electricity company or the distribution company can turn off the interruptible power supply using a smart meter or a ripple relay and disconnect the electricity from your water heater. So if you find that inconvenient, this is a solution that's available where you have two power connections to the water heater. You have an interruptible power supply to the bottom element, so the power company can still reduce load on their network, and you have a continuous power supply to the top element. So you'll always have that 45 litres of hot water, one shower and a sink of dishes, that'll take about an hour to reheat. Now, when you do this, potentially you're going to have both elements running at the same time. So the size of your power connection needs to be taken into account if you want to take this option. But again, for those that may have a little more power supply available, it's something that's worth considering. So the third thing we need to have a think about is where we're going to put our electric storage water heater. And we'll have a look at some direct application examples towards the end of the webinar. But we can put it inside, very traditional place in New Zealand houses, hot water cupboard, often centrally in the house, has the advantage of short pipe runs to kitchen sinks and to showers. The disadvantage is that it's obviously using up valuable real estate. We can put it outside. Rinnai, for example, has a large range of colour steel wrapped cylinders that can go inside or outside. It can go in the attic. Again, we have a range of short cylinders that can go in many attic spaces or under stairs. Under the floor, if your house is up off the floor, under the floor is a really good solution because you usually have very short pipe runs from the water heater to your kitchen sink. We need to consider when we are selecting a water heater location that we need to have it close to the kitchen sink. Now, the building code clause for energy efficiency H1 refers to table 5 of NZS 4305, and that dictates maximum pipe lengths and diameters from the water heater to the kitchen sink. Now, we often get requests for information coming through from architects that have originated at councils questioning the placement of the water heater, and the council's often quite correct in that the water heater is too far from the kitchen sink. So you want to try and work well within these maximum lengths. Depending on the flow rate and the taps you've got, 7 metres of 20 mil pipe might be 30 or 40 seconds to empty the cold water out of it. And at your kitchen sink, that's a fairly long period of time to wait. We end up doing a lot of specifications where we have a main water heater close to the bathroom or bathrooms, and often that is well separated from the kitchen. So we're often looking at underbench cylinders in the kitchen or scullery. So an underbench cylinder as an addition provides near instant hot water at the kitchen sink, and it's well worth thinking about. And then a ring main. So a ring main for larger houses circulates hot water from the hot water heater around the building, and you have near instant hot water from the fixtures. And we're not going to cover that today. We have a webinar that we'll give you a link to at the end, where if you're interested in ring mains, you can go and do some more study on those. If we have a look for a minute now about underbench hot water cylinders, this is a little 30-litre one that we do, sort of in a colour to match your cabinetry. We also have a 50-litre one. Now, a popular place to put these is in that corner cupboard of the scullery or the kitchen, that tricky shelf we're looking at is probably $2,000 or $3,000. So rather than pony up for that expensive, really cool shelf, but they're very expensive, the suggestion is that you pop your water heater in that corner cupboard and use up that space to get near instant hot water in your scullery or kitchen sink. We have a 30 or 50 litre, and often we see plans where there's a toilet basin not far away, and that water heater can be used to feed that separate toilet basin. So that's undervent cylinders. So that's really the finish of the electric storage water heaters. If we move on to the heat pump water heaters, this is the Rinnai New Zealand range that seems to be expanding on a monthly basis. Integrated products to the left, and a split heat pump that can be connected really to any size of storage water heater on the right. So if we have a look again at the volume that we might specify when we do a heat pump water heater, something to bear in mind is that heat pump water heaters, because of the way they're designed in order to operate efficiently, they tend to leave a little bit of cold water in the bottom of the cylinders at the end of the heating cycle. So we get around 75% of the stored volume out of a heat pump water heater rather than 90% with the electric storage water heater, which explains why generally heat pump water heaters are slightly larger than a electric storage water heater. The other factor is that in order to be efficient, most domestic heat pumps only heat the water just over 60 degrees. They become inefficient if they heat with the heat pump to a higher temperature than 60. So we've got a little less temperature and a little less volume of water stored in the heat pump water heater, so we need a little larger cylinder. So if we take the same 160 litre application we had before, we divide that by 75%, we come out at about 215 litres. So our heat pump range starts at 215 litres and gets larger from there up to 340 litres. If we now think about recovery, a heat pump water heater recovery rate is similar to a 3 kilowatt element, but it'll recover faster when the ambient conditions are warm in summer, and it'll recover slower when there's cold air temperatures in the middle of winter. A boost is often available from an electric element, both to speed the water heating when conditions are cold, and also you can ask your water heater either once or on a regular basis to increase the temperature of the water. Once the heat pump stops, the element kicks in and moves the whole stored water onto a higher temperature that you might select if you've got a very heavy hot water day coming on. All the kids are at rugby on a Saturday morning and you want a bit more hot water. The electric element can provide a boost. If we look now at location, there's a few things that we need to consider for heat pumps that are a little bit different to an electric storage water heater. So we need to think about whether we're going to have an integrated solution or a split solution. The heat pump, generally in New Zealand, the heat pump is located outside, and the Rinnai solutions, the heat pump head needs to be located outside. We can think about a split system where we have the heat pump outside and then the tank can go inside or outside. So potentially we can leave the storage tank in the hot water cupboard where it's always been, with the pipe runs nice and close to the kitchen sink and the bathroom. And then we can have up to 20 metres of pipe run between that cylinder and the Rinnai HydroHeat split sitting outside. We can also use that HydroHeat split to retrofit to existing cylinders. There's a selection of cylinders, pardon me, that we're confident it will work with, that are shown in the manual for the product. If we've got an integrated product and we can't get it reasonably close to the kitchen sink, then we may wish to consider having the integrated system in the service court, feeding the bathroom or bathrooms, and then an underbench electric, small underbench electric, as we saw previously, in the kitchen or scullery, supplying hot water to the kitchen sink. Noise is something that you need to think about that's not a factor with electric storage water heaters, which are silent. We don't want to place the heat pump head where it's going to wake up someone in the building at night or annoy the neighbours. So noise is a factor we need to consider with the heat pump water heater. So that's the location. A question that we were at the Auckland Home Show recently, and we had a large proportion of people come and talk to us about water heating options that we're considering putting solar panels on the roof of their house. So we've come up with a brochure about the solar water heating solutions. So please get in touch with the team and ask for a copy of the brochure. So there's two basic options that we can look at. The first is an electric storage water heater with what's called a solar power diverter, and I'll explain how that works in a minute. Well, the Rinnai EnviroFlow GR heat pump can be configured to work with solar systems, and we'll see how that works in a second too. So these solutions are for grid-connected solar PV. They're not for off-grid solutions. The reason for that is that when we've got not much sun, we need to still heat the cylinders up in order to disinfect for Legionella. So the controllers will take care of that, but if they haven't got a mains power connection, they're not able to do this disinfection job. So the solutions are really for grid-connected applications. If you've got a particular client, there won't be many that are wanting to go off-grid, you really need to consult a specialist as to how they're going to assure that they don't have a cylinder full of bugs when the sun isn't shining strongly. So solar power diverter, you can see it in the middle of the picture there. It's a magic box of tricks. If I wave my mouse around a bit, it is connected to what's called a current transformer. It's a little sensor that sits on the power line coming in from the street, and it monitors whether power's flowing in from the grid. In other words, you're buying it for 30 cents a kilowatt hour, or whether you're shipping it out to the grid and the power company and their generosity is paying you 12 cents a kilowatt hour for that power. When the power diverter sees you shipping electricity out to the grid, it knows how much you're shipping out, and what it does is it diverts that same amount of power to the water heater element. And so it might be as little as 100 watts, it might be as much as 3 kilowatts. And the element of an electric storage water heater is a very simple device. It doesn't mind if you just put a little bit of electricity to it, up to its maximum power supply. So if we're making 1500 watts out of the panels on a nice sunny day, it will divert 1500 watts into the element in the bottom of the cylinder. If you turn an appliance on in the house, if I turn my hairdryer on and I start sucking 1000 watts into my hairdryer, the power diverter will reduce the power supply to 500 watts. To the element, when I stop using my hairdryer, it'll start putting 1500 watts back into my water heater. So they're a really cunning way of using the water heater as a battery. ECA recently did a study and found that for many applications, batteries simply aren't worth it. But what is worth doing is using a power diverter and using your water heater as a battery when you have excess solar power available. So a good quality solar power diverter can shift as little as 100 watts to the cylinder element. If you get the brochure, there's one brand that we've had a look at and we suggest, but there'll be many other brands that are worth looking at. The power diverter can also be programmed so that once you've got solar, you're looking at a different electricity tariff. And it can also be programmed so that at 11 o'clock at night, when the cheap power is available, it turns on and fully heats the cylinder. So you start the day with a fully heated tank of water. So bearing that in mind, when you're sizing the cylinder, you really want the cylinder volume to be about your full day's hot water use. Another option is if you get a twin element cylinder, you can provide a continuous power supply to the upper element. So you'll always have that 45 litres of hot water available in the top of your cylinder, and that'll reheat as you use it. So you're always going to have a shower and a sink of dishes available to you. If you've got enough power, you could even knock that top element up to a 5 kilowatt element. It'll give you a pretty quick reheat on that top of that cylinder. So that's the solar power diverter. It'll work with any electric cylinder, not just the twin element one, but the twin element cylinders offer a lot of flexibility. The other solution that we offer to customers is the EnviroFlow GR heat pump. Now this does something similar but a little bit different. There's a different device here called a solar relay, and that has a couple of these sensors that are monitoring the power that your solar system's generating and the power that's going to or from the grid. When it sees you're making a reasonable amount of power and there's power being turned out to the grid, this solar relay will pull in a standard electrical relay, and there's a low voltage signal cable that comes from the EnviroFlow. When it sees the switch close, that circuit's completed, and the EnviroFlow now knows it's in solar mode. So when it sees that happening, it will initiate reheat cycles more often in order to take advantage of the power that's available. So again, this is really simple stuff for an electrician. There's a range of these solar relays available on the market, and we do make it one suggestion, I think, in our brochure on these systems. You can also have a second low voltage signal cable come out of the EnviroFlow that can be connected to a timer. So again, if you're in a warm area, pretty warm at night most of the year in the north of the country, you can, rather than running your heat pump during the day, you could run it at night on the low price electricity. So if the client's not sure what to do, and we had a lot of this at the home show, a lot of uncertainty about where prices of electricity are going, what option they want to go for, what we suggest to do is to put in a dual element electric cylinder on its own that maintains maximum flexibility. You can then, at a later time, connect a hydro heat split, or you can connect solar panels via a power diverter. If you do that later, after your building project is finished, you may be able to take advantage of a low interest loan from your bank for that sustainable add-on. So this is what we suggest to customers that are scratching their head and can't make a decision. Just go with the twin element electric cylinder. Once you've finished your project, sit back and then decide if you want to add something onto that. Electric continuous flow. So we're going to just have one slide on this to explain why they're a bit of a challenge. This is the Rinnai Efinity product, available in 18 and 27 kilowatt hours. It's really a product for single bathroom apartments or hotel rooms that are obviously single bathroom with three-phase power. It's not suitable for a standalone domestic dwelling. If you have a multi-unit project that you're interested in these products, they're excellent. You need to consult with your electrical engineering provider, because they will need to size the infrastructure, the wiring and the transformers to take them in a multi-unit development. But look for models that modulate the water flow rate as the Rinnai Gas Infinity does. So it will make sure you have a steady temperature, and that if you put too much flow through it, it'll reduce that flow rather than produce lukewarm water. So why can't we have these in our house at home? So if we look at 8 litre a minute shower, and let's say we're in Auckland and we're going to raise that by 25 degrees, which is sort of average for Auckland. That's 14 kilowatts of energy required. We now know if we multiply that by 4.4, we come up with 62 amps, and that our house supply is about 65 amps. So it's not a practical proposition to get an 8 litre a minute shower out of one of these, because we're going to use all of our available electricity. And if someone tries to cook a slice of toast, the main breaker is going to trip. So we can't use them. They are available. They generally provide miserly showers. I was recently in Thailand. Everybody had single phase products, but the water's coming in at 28 degrees and you only want to shower at sort of 35 degrees because the temperature's so hot. So in New Zealand conditions, a single phase product doesn't provide the amount of hot water that the client's looking for. The 3-phase products do for single, or perhaps in Auckland, a 2-bathroom apartment, but you need a lot of electrical infrastructure. If you've got a large house and you are going to have 3-phase power, you're probably going to have 3 or 4 or 5 bathrooms, and putting 3 or 4 or 5 of these in isn't going to be practical. You need to look for another solution. So sorry, but the electrical continuous flow sounds like a good idea, but for most, and we've got a really good one, but for most projects, most domestic residential standalone projects, it's not going to be practical. They also use a particular way that the element heats the water, and so good for metropolitan water suppliers. if you are somewhere that's off its own bore or roof water supply, the technology may not heat the rainwater. So if you're thinking about that for a factory or a remote project, give us a call and we can go through that with you. So that's electric continuous flow. Let's have a look now at gas continuous flow. So if we have a look at the similar plumbing diagram for a gas continuous flow water heater, it's a little simpler than the electric storage water heater. So we've got cold coming in. The water heater heats generally, in this case, to 50 degrees. Cold to your shower mixer, and here we are having our shower at 40 degrees. So we've got our same, let's say, 10-degree incoming water temperature. The water heater is set to 50 after the 2nd of November last year. And we mix that with cold in order to get 40. Now, what we're finding is that some people at new installations are saying that 50 degrees is not quite hot enough at their kitchen sinks. So we need to make a slightly more complex solution. So we have the water heater now set to 60 degrees, and we take that 60-degree connection off to our kitchen and laundry. We could take a 55-degree off to our kitchen and laundry, but we're allowed to have above the 50 degrees. We then install a mixing valve under the water heater to mix the water to our sanitary fixtures for personal hygiene, so our showers and basins, to 40 degrees. We've got that mixing valve sort of hanging around under our water heater, so we might consider putting a pipe cover to hide, make a nice, neat, tidy installation, and of course we have the option of a graphite product. So that's how we're going to install it. If we have a look at how big do we need. So when you look at our various models, 20s, 24s, 26s, what that is the flow rate in litres per minute at a 25-degree rise. So in order to get our actual flow rate that we're going to get, we need to multiply that badge rate. We multiply it by 25 and we divide it by our actual rise. So in this example, we're having a really hot shower at 40 degrees and we've got 10-degree incoming water heater, incoming water. So we have a 30-degree rise required. This particular model is the high efficiency condensing product, well worth considering for your project, for LPG in particular, about 10% more efficient than our normal product, but that'll do 26 litres a minute at a 25 rise. So what will it do in this application with 30-degree rise? We multiply 26 by 25 over 30 and we get 22 litres a minute. So we'll get 22 litres a minute at that 40-degree showering temperature. So plenty for 2 showers, maybe even at a stretch, we'd get 3 showers out of that one. If we move to the South Island, where the water temperature's a bit lower at some times of the year, and we're multiplying that by a 25 degrees divided by now a 35-degree rise, we've got about 18.5 litres a minute. So still plenty for 2 showers, but perhaps not quite enough for 3 other than in the summer. So that's how we do our capacity calculation on a Rinnai Infinity. So in order to specify it, it's different. We're not worried, obviously, we have no stored volume. We're not worried about how much storage. What we want to know is how many taps you've got in your house, how many of those you want to run at the same time. And what we want to know is the flow rate from each outlet. So are you a standard 7 to 8 litres a minute, or have they got a rain dump shower that they're wanting to run at a much higher flow rate? And with that information, we can size up the water heater we need. So location of our gas continuous flow water heaters. Outside, obviously, when we do that, we need to be mindful of windows and openings. NZS 5601 has a table and a little diagram that shows you where you can put them. Consider that the clearances in that drawing are from the flue, not from the whole appliance. So if you can get that flue terminal just fractionally above the top edge of a window, you're good to go. You don't need to get the whole appliance above the top edge of a window. If you're struggling, get in touch with us and we can see if we can help you out with that. We can go inside. The model on the right is the Infinity A28 internal. You need to consider the flue route. You can obviously go horizontal or vertical. You can put offsets in the flue. You can't really go down. But again, trying to find on a 2-story building a perhaps it corresponds with an upstairs wardrobe, and we can box out in the corner of a wardrobe to run a flue. So again, get a hold of the team if you're after some help on where you might position an inside water heater. An attic usually means that you've got easy access vertically. Under the floor, if your building's on piles and you want to go under the floor, you could use an outdoor unit. We don't really like them tucked back under the edge of the building. We want them to sort of be flush with the edge of the building, or nearly flush if we can. The water vapor that's produced by the water heater when it combusts gas is mildly acidic, like vinegar, and it will deteriorate building elements over time. So we don't want the water heater tucked way under the floor, aiming at your joist hangers and galvanized or any other structural elements. So in line with the cladding is good. If you want to tuck it right back under the floor, then we really want to be running an indoor unit with a horizontal flue going out to the edge surface of the building. So let's have a look now at some example specifications, a fairly simple plan, and let's have a look at the different water heaters we've looked at and how we might apply those to this plan. So we've got a simple 4-bedroom, 2-bathroom house with a kitchen and a scullery. So if we want electric indoor water heater, we can occupy this cupboard, which would be the sort of the traditional installation. We can go into the attic. We can look at a squat cylinder. We've still got a little bit of space there looking at the roof line that's shown. But we're nice and central there. We've got a reasonable pipe run to our kitchen sink, a little further to the ensuite. We try and get closer to the ensuite if we can, because that's the people paying the bills usually. But this would be a reasonable compromise for a simple house. If the client decide they don't want it in the attic and they don't want to lose that cupboard space, we can have a look at an electric outdoor cylinder. So we've now, over at the service court here, we've got a cylinder sort of halfway between the bathrooms that'll work pretty well. But we're now much further than our 7 metres to our kitchen and the scullery. And even if we sort of slipped it past the council, the client would be pretty unhappy about how long the water's taking to get to the kitchen sink. So in this one, we want to go with our old friend, the under sink or under bench, and utilise that space in the corner there. And we're going to have a really short run now to our scullery and kitchen sinks, and the customer's going to be really happy with that as an installation. If we have a look now, we want an outdoor heat pump, an integrated unit. So again, that's where we had our outdoor electric water heater. Bearing in mind the noise factor, and everything's a bit of a compromise, we'd want to make sure that the neighbour's master bedroom wasn't right the other side of that boundary line shown at the top of the picture. But that might be a little bit annoying for bedroom 3 if the heat pump was there. So we're going to shift it down a little bit to get it a bit further away from the bedrooms. Now that's going to have a longer pipe run to the ensuite. So we have to have a bit of a discussion with the client about what compromise they're wanting to make. A little bit quieter, a little bit longer to get hot water to the ensuite. Again, we're now too far from the kitchen sink, so we're going to be back with our underbench electric in that corner cupboard. Let's have a look now at a split heat pump. So with a split heat pump, we can get the cylinder nice and central, either in that cupboard or in the attic. And we're going to choose our heat pump location in that service court. Will be well within the 20 metres of pipe run required, and that's going to be a cylinder either in the attic or in that cupboard. So that's a nice solution for that house. A gas continuous flow. Again, we can have an internal flued vertically in that cupboard or in the attic above. If the customer and or the architect decides they really don't want to ruin the roof line with a vertical flue system, we could, on this occasion, go to an outdoor gas continuous flow. And again, for noise purposes, we probably want to be by that bathroom rather than outside that bedroom 3. And once again, we're going to be looking at a underbench electric. So hopefully you're sort of getting the theme here. Underbench electric cylinders are pretty useful. If the client's got a few extra dollars that they're prepared to spend, it gives a really good solution. And that is the end of the presentation part of the webinar. So over to you, Alice.
Thank you very much for that great presentation, Grant. Personally, I really like the specification examples, especially with all the options out there these days. We often get asked about different options. So it's great to have these clear examples to refer to. Before we jump into Q&A, I've popped 2 links in the chat. The first one is a quick survey, just a minute of your time. We'd love to hear what you thought of today's session and what topics you would like Rinnai to cover next. It also helps me recording your CPD points. The second link is to our Rinnai CPD webinar playlist on YouTube. The next slide, please. It's a great mix of content, which is perfect for lunchtime watch. Here's the list. And the Rinnai Systems Advanced one is the one that Grant referred to. It was for gas-fitted plumbers mainly, but there are some really valuable information in that webinar. And lastly, our contact details for the specification team. If you would like to book a presentation or just have a chat about your projects, we would love to hear from you. Now, Q&A time. Here are some questions that we received before the webinar and also during the webinar. So the first one, Grant, let me bring you back to screen. Hot water heat pumps suitable for all climate zones in New Zealand?
So certainly the Rinnai heat pumps are tested for all climate zones in New Zealand. They will absolutely work better or more efficiently where it's warmer, but they will absolutely work in cold climates. They may, if they have extremely cold conditions, such as central Otago in the middle of winter, they may use their electric elements a bit more often if they detect that the heat pump isn't working that efficiently. And the heat pump may start to ice up in the winter. It may switch to using the electric element, but they'll absolutely work.
Thank you, Grant. What are the benefits of having infinity to cylinder electric storage?
Well, obviously they're never going to run out of hot water. So when I grew up, we had 4 of us in the house, 3-bedroom house, 4 people. We had a 135-litre cylinder, which was pretty standard then. And I got regular clips around the year from my father for him having a lukewarm shower after I'd been in the shower for 40 minutes. And so my son has never experienced that because we've always had gas hot water. So having an unlimited shower is just what he's grown up with. If we go to an electric solution, he will have a pretty good go at running it out, no matter how big I go. So it's just when you're going to electric, when you've always had a gas continuous flow water heater, you need to be mindful that you're going to have to, unless you go very extreme on your electric solution, that you're going to have some limits to the hot water that you use. And perhaps for a period, that means someone's going to be the hot water police. Of course, clipping children around the ear is no longer acceptable. So I'm not advocating that. So the main advantage of the gas water heater is you're not going to run out of hot water. For larger architecturally designed homes, these 4, 5, 6 bathrooms, the client really needs to engage with their water heating solution if they're going electric or heat pump storage to understand that they're not going to get the same volume of hot water that they've been used to having. And Rinnai Infinity 26 will do plus or minus 1,000 litres of showering temperature water an hour. So that's a fairly large electric storage solution you're going to need in order to do that. You can absolutely do it, but unless you're spending an awful lot of money, you're going to have some thoughts about limiting a little bit your hot water use when you move to electric storage.
Absolutely. This question is from Corey. Do you have details for exterior hot water cylinder seismic restraints for various claddings? Ideally, something nicer than galvanized straps and blockings as per New Zealand Building Code.
Okay, so that's not a solution that we have. I'm not aware of any blocking solutions that look really nice. We have talked about that from time to time here. In terms of the fastening solutions, again, we We don't have it. Usually for seismic restraints, my go-to company that I refer people to is a company called Ray Stager Limited that produce the simple fix solutions. They have a stainless steel option, and they have a really good brands appraisal, which is why I normally reference people to the simple fix system. I'm not sure what their fastening system options are, but they are the specialists on seismic restraint systems. So I would Google Simple Fix or Ray Stager, Staiger, something like that, and get in touch with them because they're the experts on that.
Great, thank you. Next one is from Joseph. In addition to turning off the heat pump from 10 p.m. to 6 a.m., what other options are there for the noise issue?
Obviously, with a split heat pump, you can position the heat pump head up to 20 meters away and try and find a place that isn't going to annoy the neighbors or the client. So that's the first thing to consider. Other than that, you're looking at some sort of acoustic engineering and consulting an acoustic engineer in order to make that solution. The other obvious answer is to stick some solar panels on your roof and use the solar PV solution, which will be completely silent, I suppose, if you have that option.
Thank you, Grant. And final question. So given the situation with gas, heat pump water heaters seem to be the best option at the moment for power efficiency. Can you give an idea of investment required for budgeting purposes, ballpark figures?
So a pro forma sum for an electric storage water heater installed in a new project is about $3,000, just as a give us a baseline. A heat pump water heater, depending on the one you have, sort of $7,000 or $8,000, depending on the model that you're going to go for. So yeah, heat pumps have become really, really popular. We are moving a lot of them, but don't, particularly for smaller projects, for retired couple building their house that they're going to retire in. Don't discount the solar option, because getting a payback on a heat pump can be a bit of a challenge if you're not using much hot water. Using lots of hot water, it's a great solution. But yeah, consider the solar option for if it's just a couple.
Thank you very much, Grant. And thank you everyone for joining us today. And we hope you found the session useful. We'd appreciate it if you could please take a moment to complete the short survey. So enjoy the rest of your day. Thank you again and see you next time. Mā te wā.